Thank you for your participation on the Collaborate board. And so before we look at area of a sector, we're going to look at area of a circle. And you've probably learned the formula for area of a circle in one of your other math classes, that the area is equal to pi r squared. Have you ever wondered where that formula came from? Well, the formula for the area of a circle is derived from the area of a parallelogram. So imagine we take our circle and we cut the circle into wedges. And then we take those wedges and each time we flip them to create the shape of a parallelogram. Okay? Well, the area for a parallelogram is equal to the base length times the height. And that height is that vertical distance. So base and height have to be perpendicular to one another. All right, so here we have our parallelogram created by the wedges from the circle. Our base is this length here. That represents half the distance around the circle, right? Because we alternated each one. So the bottom is one half of the circle and the top is the other half of the circle. Right? So now let's think about how do we find the length of the circle. Right? So if we want to find the length of a circle, we take circumference, right? Circumference is the outside measure of the circle. And so the formula for circumference is 2 pi r. But we don't have a whole circle, we have half a circle. So then we have an arc length. So we're going to take the fraction of the circle, 180 degrees over 360, which is just half a circle, times 2 pi r, the formula for circumference of a circle. The 1/2 and the 2 will cancel, so that gives us the length of that arc as just pi r. Whatever the radius is, that would be the length of that particular circle. So there we have our base measure. So the base of the parallelogram here is pi r. How about the height? Right? So this distance from the arc on the circle to the center, not well drawn, all right, there we go. That distance there from the arc of the circle to the center is the same as this distance from the arc of the circle to the center. Right? And so what is that distance? That goes from the outside of the circle, the edge of the circle, to the center of the circle. Well, that's a radius. Right? So the height of our parallelogram that's formed by the wedges of the circle is a radius. And so if we use that formula for the area of a parallelogram, area equals base times height, we have area equals pi r times r. What's anything by times itself? Well, r squared. It's that thing squared. And that gives us the formula for the area of a circle. That's where that pi r squared comes from. All right, so we're going to use the formula for the area of a circle to find the area of these two. Now, remember with circumference, we had one formula for if we wanted to use the radius of the circle and one formula if we wanted to use the diameter. No such thing here. All right, we do have to use the radius. All right, so in a moment, the tape is going to pause. I will write down what these measures are on and a question is going to pop up. So the first question will tell you that you're finding the area of a circle with a radius of 12 feet. Right? So now I want you to find the radius and select the answer you think is the correct, I want you to find the area of the circle and select the answer that you think is the correct area, and then I'll go over the answer afterwards. Right? Right. right, welcome back. So now let's find the area of this circle. So the area is equal to pi, our radius is 12, squared. Now 12 squared is just 12 times 12, which is 144. So our area is going to be 144 pi, and we use square units, so that's feet squared. All right, so now the tape is going to pause again, and this time you're going to find the area of a circle with a diameter of 30 feet. Choose the answer you think is correct, and then I'll go over it momentarily. And welcome back. All right, so now let's find the area of the circle. Now I can't use diameter, so I do have to use radius. Remember that radius is 1/2 the diameter. So that means the radius for this circle is half of 30, or 15 feet. That means the area is going to be pi times 15 squared. 15 times 15 is 225. Oops. Almost forgot to write the 5 in before I started to do the pi. 225, which makes the area 225 pi feet squared. And there we go. So there's an overview of finding the area of a circle. And hopefully that wasn't too bad for you. But our goal is to find the area of a sector, because area of a circle is something you already know. So the sector of a circle, remember, is the region bound by two radii and their intercepted arc. Right, so we have two sectors here. Both of these are sectors. Right? We have the smaller blue sector, and we have the larger red sector. Both of them are bound by a radius. There's the radius. And the intercepted arc. Right? So there's one, and here would be the other. I don't know how well I'm going to be able to draw this. Oh, a little glitch there, but not too bad, really. Well, both in the same spot. All right, so visually it might remind you of a slice of pizza, or a piece of pie, or a very large piece of pie if you're eating the red part. Leave one piece behind and eat the rest. So just like an arc is a fraction of a circle and a fraction of the circumference of a circle, sector area is a fraction of the area of a circle. And you're going to find that it's calculated a lot like the arc length is. All right, so with arc length, we took the fraction of the circle times the formula for circumference. With the area of a sector, we're going to take the fraction of the circle times the area of the circle. Right, so a sector of a circle is a region bound by two radii of a circle and their intercepted arc. So we have two sectors there. So I will generally shade the sector because there's two sectors there that are called ACB. Right, so how do you know which ACB? The smaller one or the larger one? Right? So you might assume the smaller one if I don't tell you, and that one, you know the arc measure for that one, or the central angle measure for that one. But usually I'll shade them so you know which one. You have all of this in your notes, but I'm going to have you add the part at the bottom because I think that's a nicer way to write the formula for area of a sector. So for the area of a sector, remember central angle equals the arc. It doesn't matter whether you have, if you're given the measure of the central angle or the intercepted arc. The area of a sector is going to be the central angle over 360. That gives us the fraction of the circle times pi r squared, which is just the formula for area. So we're taking a fraction of the area. If we took the whole area, we'd have just the area of a circle. Since we only want a part of the area, we're going to use the central angle over 360 to tell us that part. Because if you notice, right here we have a central angle. So literally like we cut out the central angle, right? So we're finding the area, it's called the sector, right, rather than the central angle, because a central angle is just the angle. The sector includes all of the circle. That's in between those two radii. All right, so we're going to find, and I don't have, actually I could have the notes in front of me. I'll go get the notes in front of me. Okay, now I have the notes in front of me, so I can tell you which ones are in your notes. This one is in your notes, and so is the steps. I put them right on top. Oh, I forgot to tell you that but I'll tell you when we're doing the live lesson, that the two areas of the circle were in your notes as well. And so the things you should have already in your notes are the two areas. Right? And I can pause in class, or you can pause if you're watching this. And then the bottom part here, you can put it right to the side. It would fit pretty nicely. And then this one we're going to do is, so we're going to actually do, you've got 6 in your notes that we're going to do. And they're pretty easy to find because they're the shaded ones. All right, so let's find the area of this particular sector. We'll always leave our answer in terms of pi. Right, and we'll and as a simplified fraction, just like we did with arc length. Here are the steps. You have them once in your notes. First of all, we'll take our formula, which is, and you'll have to write this down, arc length, and in this case, well, I'll just put arc length, the general formula. Arc length equals, my equal sign, central angle over 360 times pi r squared. All right, so we're finding the length of JH. Excuse me. Oh, we're not finding the length of JH, and we're not finding arc length. Oh my gosh. Sector area. After doing two videos on arc length, although I wrote the right formula, I had arc length in my head. All right, so we are finding the area of sector JGH. And that's equal to 131, which is the central angle, over 360, which is the whole circle, times pi, and then the radius is 12 squared. And I like to put a 1 there just so I, just keep everything nice and lined up. All right, so we have substituted. Now we're going to square. You do have to square before you reduce. Now, technically, you could reduce within the central angle over 360, but I find it easier just to square, and then you can reduce anywhere you want. So JGH equals 131 over 360 times 12 squared is 144. All right, so now 131, that is a prime number, so we're not reducing anything there. All right, so we could reduce the 360 and the 144. They're both divisible by 12, right? Because 36 is divisible by 12, so is 360. All right, so 36 divided by 12 is 3. 360 divided by 12 would be 30. 144 divided by 12 is, of course, 12, because that's 12 times 12. And we could still reduce again. So 12 and 30 are both divisible by 6. Right? So 30 is 6 times 5, and 12 is 6 times 2. So we've got 131. We've got a 2. Of course, we have the pi. And then we have a 5 in the denominator. So that means the area of the sector, JGH, is going to be 131 times 2 will be 262 pi over 5, and this is in meters squared. And there we go. All right, so it's just as easily as setting up your formula, squaring, reducing, and then multiplying and simplifying. All right, let's do another one. All right, so let's find the area. This one is also in your notes. All right, so we're going to find and I'll write the formula each time. I guess I erased it. So to find the sector area, we'll just abbreviate SA for sector. Maybe if I write it over here. It's going to be the central angle over 360 times pi r squared over 1. Just put it over there. All right, so this is sector ABC. So that's going to be the central angle, right? So the arc and the angle are exactly the same. So that's 25 over 360 times pi. The radius is 5 feet. Let's put this over here as well. Over 1. Our first step will be to, let me put parentheses so it doesn't look like 52. Our first step will be to square the 5. So we have ABC equals 25 over 360 times 25 pi over 1. Remember, you can only reduce numerator to denominator when you're multiplying. Well, 360 and 25 are divisible by 5 because anything that ends in a 0 or a 5 is divisible by 5. So 25 divided by 5 is 5. 360 divided by 5 is, so 36 divided by 5 would be 7. There'd be 1 left over. 10 divided by 5 is 2. And although it seems like a pretty big number, that's it, because all I've got are 5s in the numerator, and 72 is not evenly divisible by 5. So the area of sector ABC, 25 times 5 would be 125 times pi. Oh, I should circle, just, although not much. And you know, I don't have to always cross reduce. I could have reduced the 25 and the 360 within the fraction. I don't know. I just saw that one first. So 125 pi over 72, and this is feet squared. And there we go, another one done. All right, let's try another one. All right, so let's find the area of this sector, and this one is also in your notes. All right, so we have, and I'll just put the formula over here again. So sector area equals central angle, or the arc, over 360 times pi r squared over 1. So this is arc ACB this time. So the central angle is 90 degrees over 360, the whole circle. And the radius is 1. Oh, this is going to be pretty easy numbers, huh? So that's pi times 1 squared over 1. Well, of course, 1 squared is 1. So, and 1 times pi is just pi. So the only reducing we're going to do is within the fraction there, 90 and 360. Of course, we could cancel out the zeros. And I hope you remember that 9 and 36 are both divisible by 9. So 9 divided by 9 is 1. 36 divided by 9 is 4. And that makes pretty much sense because that's 1/4 of a circle. So the area of sector ABC, or ACB, so 1 times pi, that's just pi. So pi over 4, or 1/4 pi. And that is meters squared. Right? So this is going to be similar to some problems that you'll have as homework. This one reduced really, really nicely. Right? That was a pretty easy reducing there. All right, let's look at this one. This one is also in your notes. Right? And as a reminder, arc length, or excuse me, sector area is central angle over 360 times pi r squared. Right, so our central angle and our arc are exactly the same. This is also 36 degrees. So sector JKL, getting tongue-tied today, is equal to 36, the central angle, over 360 times pi. The radius here is 16 inches over 1. All right, so let's square first. So JKL is equal to 36 over 360 times 16 times 16 is 256. And I hope right away you see a really easy reducing. 36 and 360. 36 divided by 36 is 1. 360 divided by 36 is 10. We could reduce one more time because 256 is even and 10 is even. So look for things like even numbers. They're always divisible by 2. 256 divided by 2 is 128. 10 divided by 2 is 5. And now we're done. Right? So we've got the 128 and the 5. So the area of sector JKL is 128 pi over 5 inches squared. And there we go. Right, so I think I'm going to save these couple challenge problems for the next video. And I'll end right here so you can do some practice problems. All right, thanks for watching, and bye for now.